success. We're more apt at designing 1000 volts DC power distribution system than using Zoom. Okay, well, for those new to this presentation, this is also under the data center facility and modular data center track. It's a quick presentation on data center metrics. And the topic of discussion is it PUE or is it efficiency that we're looking for? And in a way or another, I call that a metrics deficiency, but maybe it is an opportunity for improvement after all. I am Gabi Mendreci. I am the captain of the innovation team at Positronic and also the director of sales for Europe. And I'd like to go into the objective of the discussion is this: if we talk about a car which travels with 95 miles per gallon or uses 2.5 liters of fuel per 100 kilometers, we understand instinctively how efficient that car is. When we go to purchase a Toyota Prius, we know by default how efficient that car is in comparison to a Dodge Charger muscle car, let's say, not to put the muscle car down, but obviously the rate of consumption is implicitly tangled with efficiency. And when we talk about the engine's thermal efficiency, however, or how well it creates work from fuel, we don't know how far that car is going to travel. So there are two different things. And this is going back to the comparison between PUE and efficiency. And definitely when we go to the data center, and I want to take that analogy to the data center, obviously data centers don't travel. And we know for sure that they use a lot of power, a lot of electrical power in kilowatt hours. And the tangible output is also different because the output is heat. A lot of heat is generated, and then we spend more energy to manage that heat. So the problem is really significant when it comes to looking at the same parameters as we're looking at a car. However, if we look at what do we charge for? We charge for data. And when data services could occur in various ways, you transmit north and south, which means in and out of the data center, but also a lot of transmission of data happens laterally, like east-west type of transmission. We charge for that service. This is the service that is being charged to the customer, but we pay for kilowatt hours. We actually pay for the power utilized to transfer all that data. And it only makes sense to think of that metric that we need in terms of gigabytes per kilowatt hour rather than PUE and all that, or all those other forms of the approach on efficiency that we all know about. And another fact to take into consideration is that in the power distribution system in the data center, there are a lot of power losses, and there are insertion losses. Every time in a transmission line we insert an element, that element will have some insertion losses. When we're talking about main power coming in and just the down conversion from there, and we're looking at all the transformers involved in the system, there are transformer losses, although that technology is pretty up there in terms of efficiency. However, insertion of all elements come into place. The actual length of lines is a problem as well, even connectors, and also conversion losses, like every time we need to convert from DC to DC has its challenges, and all the power distribution units accordingly. And we have here a pie graph from Big C 002 showing, in fact, what level of electrical losses exist into the electrical systems, basically. So 15% of power has been lost due to electrical losses. And of course, we don't want to go to the heat exchangers, of course, and then there's cost in pumping and in moving mass. Managing thermal management, it equates to moving mass. The more mass you move, the more heat you move out, right? So that's also between these two elements here, we can see that's a high percentage. And in terms of electrical losses, I just want to make a very huge, shocking example. if you take two different power input connectors and you put them in 24/7 operation, and because one uses, let's say, high conductivity materials or special type of interface at the contact, and the other one's like more generic, let's say, and one has a circuit resistance of 0.46, so under half a milliohm, but the other one has like 5 times lower, like 0.13 milliohms total circuit resistance. The lower resistance connector, and that is crazy, over one full year, 24/7 operation, will give 55 kilowatt hours of energy savings. And that's $7 at California energy, industrial energy per kilowatt hour cost. And so that's $7 in savings per connector. One connector, $7. Imagine how many shelves, how many racks, and how many data centers are out there. And basically this translates in money, and money, this just burns. And efficiency, the message here is efficiency starts from the component level, and we need to be aware of it. Wire, the size, length, connectors, connections, everything. So there's a new world of education that we need to embrace and adapt in order to learn how to be more efficient. What would be the resulting impact? Obviously, we want to create competition for real efficiency. We want to generate competition so companies and their products become, rated upon like their efficiency, like the Energy Star. We go and buy a refrigerator, we look at its Energy Star rating. I want the A++ one. Why pay money for the B one, right? Even if it's cheaper, you don't want to buy it. Well, that type of competition for efficiency could occur with the large service providers, and if that is the output of this effort, it's going to be well deserved. Now, an efficiency indicator like the gigabytes per kilowatt hour will be indicative of the facility's efficiency, not the facility's size. You can have a huge data center or a very small data center, and you can just look into that metric, gigabytes per kilowatt hour, and you understand that it's not significant how large or small that data center is, but how efficient it produces data with the amount of energy taken in. Obviously, it's more complex than that. We all know it, but it's another way of looking at converting gigabytes to dollars, because the kilowatt hour is sort of like a commodity already fixed. So the cost will be easily gauged very quickly when this type of metric exists in place. We want to lead to that type of competition that drives innovation. Obviously, when you compete for efficiency, innovation will be driven. Where do we start? We want to test the concept. We're looking for pilot facilities, maybe start with simple methods and apply an incremental approach, the type of approach that goes from outside in or from inside out. Outside in, just look at billing and see how much we're billing out. And from that amount of billing, we look at our invoices for power, and we look at our billing for services, and then we correlate the gigabytes per kilowatt hour from there. It'd be a very simple outside in approach. And of course, from inside out is actually looking at the performance of each equipment part, system, components, and so on. Now, with all that being said, in the resource and energy KPIs, even from OCP, we understand PUE has its place, energy reuse efficiency has its place. All these elements don't have to go away. We're not talking about eliminating the power usage effectiveness. That is a real metric as well, but it tells us a different side of the story. It's something totally different. And I know my friend John Laban will come up and say, yeah, we talked about efficiency years ago and we figured it out. Server virtualization took reduced consumption by up to 66%. Yes, of course, but the demand for power keeps going. The demand for computing keeps going, and we will need to look to save everywhere we can. So we understand server virtualization. Maybe it hasn't matured. It's not past news. Maybe we'll continue to define server virtualization and find new ways of doing it. However, that has a limited place in the evolution of the data center, and we have to look at the new ways of improving efficiency. That's basically my presentation. I want to come back to the slide to call for action. And if anybody's interested to learn more or participate or have any great ideas that we can start experimenting with, please contact Rob Coyle. And of course, here's my contact information as well. I just hope that this is a good start for something to think about. And, let's try to contribute to arrive to those changes. Any questions, please?
Hey, Gabby, there were a couple of comments that were made on the comment section of the FM Virtual platform. I've dropped one of them into the chat here. We've also just had someone join the Zoom call. Joey, I'm not sure if they have a question that they'd like to ask.
Hey, Joey, how are you?
I think he is still getting his audio set up.
Okay.
But I did drop a question into the Zoom chat. I'm not sure if you...
I could see the Zoom chat. Yes, thank you. Now here, I'm going to read the question first before Joey, you're on mute, but give me a second to read this question. What about the cooling restriction? Is there any safety concern related? Oh, that's the previous one. Question, how can you promote competition amongst the service provider if OCP is pushing for open common solutions? That's a great question. And obviously OCP is pushing for open common solutions, but I'll give you a simple example because I'm the connector guy. We know that there are different connector manufacturers out there and they all make a product that's compatible to the spec. However, if I make a connector that's a lot more efficient than my competitor today, that means that tomorrow is going to make a connector that's more efficient than mine. So that will push me harder to make one that's even more efficient. So the same type of approach will go to everything else. Joey, it's your turn, but you're still on mute.
Yeah, but Joey is actually our next speaker. I apologize. I think he was just joining.
Oh, okay. Okay. So how are we doing for time? Are we on?
We are good for time. So right now it's 9:03 Pacific. You've got a couple minutes left, and then we have a 10-minute break until the next session. So if you want to use up some of that break time, that's fine. However you like.
I'm totally fine. If anybody has another question, I'll be happy to try to answer. And if not, just reach out to us, and we shall definitely engage in further discussions on this topic.
So Gabby, we do have a question from Dale Sartor. So Dale has given some great presentations so far this week, and looks like he's got a question as well. Dale is asking, how do you measure GB across applications?
Yeah, it's definitely something where we would need to figure out how it's done. How do you bill for services? That's my question right back. Is that if there's a way to bill for that service, then there's a way to measure GBs. And then there's a way to, if we know how much we have to pay for power, then we'll have to, correlate the two. What we're paying for and what we're charging for. I think that's the outside in type of approach, but would be the first quick way of looking at it. And the long-term approach would be to just look from inside out and figure out exactly what each device is capable of producing as an output. Okay.
Gabby?
Yes.
Let's see. There's some great discussion going on in the chat here, or in the comment section. Brian is making a follow-up comment. Brian, I'm just going to go ahead and read your comment out loud. Brian says, true, your connector may be differentiating, but if it's implemented in OCP, then everyone still has the same one, right?
That was just an example. It's true, everybody may use the same connector, but many times we all know that there are any number of manufacturers, so you can buy the same piece of equipment manufactured by, a different company. And the example on a connector was just an example, but we know about all types of conversion devices, and pretty much they will conform to the spec. They'll be plug and play, but their level of efficiency may differ from, supplier A, supplier B, supplier C. I just picked the connector because I'm the connector guy, but it doesn't mean that we don't have competitors, and maybe not so many on this in this type of industry. But for instance, in aerospace, I mean, it's a multi-billion-dollar industry, and you can bet there are competitors, and we compete hard on product, price, and performance. Okay. Any other questions?
I have not seen anything else come in. So with that, we can close this session. Gabby, thank you so much. Folks, if you do have any questions for Gabby, please hunt him down over the next day or two. I'm sure he'll be online on the FN Virtual platform. You can find him and chat him directly there. Thank you,
And
Gabby.
thank you, everybody, for the opportunity. I wish you a great day to continue with presentations. I'm over and out.
So folks,